With respect to the continuation of gantry girder design, we are going to do the check for the moment capacity of gantry girder, whatever the section we have chosen. Okay, so for that we are having one formula from yes. Okay, so that I will try to share right now. So from class 9.3.1, just a minute, I will share the screen also for you. So here from the class 9.3.1 for plastic and compact section. Okay, this is for combined axial force as well as bending moment. Okay, now so gantry girder we can have both things. Okay, now axial force also we can have and bending moment also we can have. So for that the condition is my by mdy plus mez by mdz should be less than or equal to 1. Whereas alpha 1, alpha 2 we are going to take it as 1. Okay, so no worry about it. So what is my and mez? That is factored applied moments about the minor and major axis of the section. Okay. So because of load, what is the moment? Okay, now about y and the x axis. Okay. Similarly, mdy and mdz. This is design reduced flexural strength under combined axial force and respective uniaxial moment acting alone. That is section 9.3.12. Okay, so we can directly calculate the values of mdz and mdy. Okay, so from we can calculate. So here we can have the formula, that is md formula. Okay, that is beta into ezpz. So class 8.2.1.2. So this is the formula for mdz and mdy. Okay. So it should be less than 1.2 times of EZT into Fy by gamma n naught. This is the condition. Okay. So this is for simply supported beam, and if it is check. Okay. Let us move on to the calculation of mdz and mdy. Okay. So the condition from 9.3.1. Okay. My by mdy plus mez by mdz should be less than or equal to 1, whereas my is equal to lateral direction. We have calculated that 21.97 kilonewton meter, and whereas mez we have calculated that uh, 676.16 kilonewton meter. Okay, now we have to calculate my and mdy, sorry, mdz and mdy. Okay, so this is a formula which here we have beta b into zp z into fy by gamma m naught. This should be less than or equal to 1.2 times of z ez into fy by gamma m naught if it is simply supported beam. So the same thing, beta b into z py into fy by gamma m naught should be less than or equal to 1.2 times of zey into Fy by gamma n naught. So this is the condition. So now we are going to apply this. So beta B value for plastic section is 1 and ZPZ we have calculated already. That is 3764.98 into 10 to the power 3 into Fy value is 250 divided by gamma m naught is 1.10 from table number 5. Okay, if I'm going to calculate this value is around 1083.63 kilonewton meter. So if I'm going to calculate this 1.2 EZ, so 1.2 into EZ, so we have calculated that value also. Sorry, here I made one mistake. So ZPZ value, this is ZEZ value. So ZPZ value is 4767.977 into 10 to the power 3. Okay, then 1083.63 kilonewton meter we are getting. And if I'm going to substitute ZEZ 3764.98 into 10 to the power 3 into Fy value is 250 divided by gamma n naught 1.10, then the value becomes 1026.81. So here it is getting, we are greater than this value, MDZ is greater than our requirement. So we are going to take this MDZ is equal to 1026.81 kilonewton meter. Okay, similarly here MDY. So beta B into ZPY. So 824.763 into 10 to the power 3 into 250 divided by 1.10. The answer becomes 187.44 kilonewton meter. Okay, and here 1.2 into ZEY value 580.92 into 10 to the power 3 into 250 by 1.10. So then it becomes 158.43 kilonewton meter. Therefore, our MDY, we are going to take it as a 158.43 as our MDY. So now I'm going to substitute. So MD is at 676.16 divided by 1026.81 plus 21.97 kilonewton meter divided by 158.43 kilonewton meter. So if I'm going to substitute these values, I can get 0.797, which should be less than 1. Hence, condition satisfied. So if the condition is satisfied means the section have the capacity to withstand the movement. Okay, so the next topic we are going to see by tomorrow's class, that is the continuation. Okay, which is that check for buckling resistance. Okay, now, and check for shear capacity and deflection check. So these three steps we can do on next class. Okay, thank you all.